In an earlier video, we looked at how to use regression analysis to estimate a very simple demand function, a bivariate regression, just price and quantity. In this video, we're going to extend the analysis a little bit by looking at multivariate analysis, because frankly, the world is complicated and there's more than just two variables involved. Now, we will keep it simple. We're still going to look at price and quantity, but this time I want to look at the effect of seasonality. And as you can see from this spreadsheet, we have this new additional column. We have a seasonal variable, and usually things are very normal. But if you scroll down, I see that there's also, I've indicated that some observations are summer sales. And summer sales might be different than what our usual is. And for this example, we also have the winter holidays designated. Christmas and Hanukkah shopping, for example. We have good reason to believe that the holiday sales might be different from summer sales and non-holiday, non-summer sales, what we're calling normal. So it's a very simple kind of scenario, but how would we analyze this data? Well, we have words here, and the first thing that we need to do is convert words to numbers. And the best way, or the easiest way for us to do that, is to do zeros and ones, to do binary variables. We can create a variable called summer. And we can create another variable called winter holidays or something. What was it called on the bottom of our spreadsheet? It was called holiday. So let's just be consistent and call that holiday. It doesn't matter what we call it. What's important though is how we make these columns that are now empty, how we get it to reflect the season in column D numerically. So here's what we're going to do. We're going to use an if statement. Basically what I want is, if what's going on in column D, if it says summer, then let's just have a 1. And if it's not summer, a 0. So if whatever is in cell D2 right now, because we're just in row 2, if this thing is equal to summer, then put a 1, otherwise put a 0. So we hit enter, and of course normal is not summer, and so we get the 0. We just copy our formula down, and there we go. We start getting some more interesting things. So here are my summers, and I've replaced this empty column E with a 1 just to designate those sales as summer sales. And we'll do the same thing for holiday. If D2 is equal to the word holiday, then put a 0 now in this new column, F. Otherwise, it's not a holiday, and we're going to have a 0. So we copy that formula down. And if we scroll down, we see that our holiday sales are indeed 1s. All right, so we've now done it. We have created two numeric variables that tell us about seasonality. Now you might say, well, shouldn't you, there's another category, there's a third category, the normal category. I don't actually need it. Not because it's normal, that was just a word, but because logically, I know that I only have 3 options in this data set. It's either summer, holiday, or normal. So if I know that it's not summer because it's a 0, and it's not a holiday because it's a 0, automatically I know that it's normal. So I don't actually need a new column, a third column for that information. It's actually already embedded in the fact that it's not summer, not holiday. So it's already in these 2 columns right here. All right, so I don't need this column anymore. I'm just going to hide that. And then we have a numeric columns. Let's graph our data and see what does it look like. So I just need price and quantity. And I'm not going to worry about the fact that economists draw their graphs differently. I'm just going to graph this thing. So let's insert a graph. it's a scatter. So I need to find the scatter, and there we go. Whoa, okay, that's a big graph. But notice that we have three different demand curves, essentially. We've got our normal one. It's downward sloping. Then we've got this other one, which I think is summer, just because there were a lot of summer observation. Then we had very few days in our holiday sales, data. And so that's this top one. And that actually also makes sense because holiday sales are usually quite large. And so there's a really high quantity for each of these prices. Those holiday sales are really high. So that's what we're looking at now. We basically don't have one demand curve anymore. We have three. Now we have to ask ourselves a question. We have a choice to make. Are we allowed to come up with three different optimal prices, three different prices, a normal price, a summer price, and a holiday price? Maybe most retail places do that. They definitely have holiday pricing. They may call it a sale, but it's holiday pricing. So we can either do three different analyses, one for each of these straight lines, or maybe we're constrained to only have one price. And what we'll do in this video is basically look at the one price version. The multi-price version, I'll show you some details, but basically just breaks down to estimating this thing 3 times and doing the earlier video 3 times for 3 slightly different sets of data. So that's not terribly difficult. But let's deal with the fact that we've got this really kind of wonky demand curve, and how we can use the fact that we've got all these different variables going on to help us pick one optimal price. So let me go ahead and get rid of this graph and jump in with the regression analysis. So we click on data analysis, and we got to find regression. There it is, regression, and click OK, and we get our familiar set of options. Our Y variable is quantity. Remember, that's our output. We get to set the price. The output is quantity. So we select C1 through C366. And then we need a bunch of X variables, more than just one. And so we've got to do a little bit of rearranging because we can't select different columns. We have to kind of select a block of stuff at a time. We've already selected C. We need B, E, and F, and we need them next to each other. So well, that's kind of a pain, but it's not that big of a pain. Let's just move our stuff over. So let's cancel this. Let's copy this column of data. And we'll move it over. We can now just delete this empty column because it's not important, and we start over again. Let's go to data, data analysis, regression. We click OK, and we start over again. Our Y variable, our outcome is again quantity. So we highlight those, 1 to 366. And now our X variables are in 3 different columns, so we need to highlight all 3 columns and then move down and all the way down. So we go from D1 to F366 in this case. The first row is a label, so we indicate that. Oops, I just lost my X's. There we go. And where do we want our output? Let's put it in this current sheet. So we can just go to the very top. Let's put it right there. And that's it. Now we click OK. Let's see what we get. We get our usual regression table. Now let me just hide this stuff now. We don't need this anymore. And let's look at what we have. We got a bunch of stuff that we don't need. Remember, we get 2 sets of upper and lower confidence intervals, which we definitely don't need. We get all of our diagnostics, which we don't need. So what do we need? We need to know what our estimated coefficients are. We basically have three sets of parallel lines. So we have our slope, what happens when we vary price, and now we have these variables that are attached to our two new categorical variables, the summer and the holiday. And then if summer and holiday are both 0, then we're just left with the original intercept. So in other words, again, the only things we really care about are these variables right here, which I'll highlight in yellow. Everything else is we don't have to worry about right now. So we can basically hide all of this stuff as well, and proceed with this. All right. So what have we just estimated? Let's take a step back and think about this. Let me get my pen. All right. So we've got our pen. Remember, we graphed. Gosh, that's horrible. We had when we did our graph, we had a whole bunch of normal sales. Whole bunch of normal sales. We had a small handful of summer sales and then an even smaller handful of winter holiday sales. So essentially we had three straight lines, if I could have drawn that one better. Now we can actually collapse all of this into one equation, and let's see how that's done. I think that'll be useful here. Normally we have y is mx plus b. But now we want to be a little bit more general. Now the way that we've done this, without getting into the really gory details, what we've done is we have three parallel lines. They differ in their intercepts. Hopefully, I wish I had drawn them a little better, but we had three parallel lines. So we basically need three intercepts. We need this intercept here, that intercept there, and that intercept right there. So rather than just one intercept, we need two intercepts and then three intercepts. But when do we know which intercept applies? Well, we have one for normal, one for winter, one for this one was summer, and this one for winter. And we had a variable, a 0, 1 variable, that told us whether we were in winter, summer, and if they were both off, then we were normal. So let's insert then a little variable here. Let's call this summer, and this one we'll call winter. And these were our binary variables. That indicated whether we were in those seasons. All right. So let's fill this in with some actual numbers. So let's grab from Excel our spreadsheet and see what numbers these are, so we can be a little bit more concrete. I was never going to remember these coefficients, so I just kind of rearranged my screen a little bit so that I don't have to keep flipping back and forth. All right, so let's keep filling in our equation here. Y was quantity. X was price. Okay, let's do this. Quantity is equal to some slope times price. So that slope was 1.787, whatever. Let's just do negative 1.78. Negative 1.78 times price. Plus, and then we got a bunch of intercepts. The normal intercept is 179. We get that right there. Then we have a summer intercept and a holiday intercept. So we're just going to keep adding to this equation. So let's think of this as one long, long line. We have a summer intercept, so it's 101. But it's only, so we're multiplying now, we're only going to have this be active if our summer variable is active, plus our holiday intercept, which is only active when our holiday variable is active, when it's 1, in other words. So let's just do a quick bit of analysis here. Like, how does this work? How do we deal with summer and holiday? Let's suppose that things are normal. So how does this equation behave when times are normal? All right, so we're going to simplify this equation now. We have quantity is equal to negative 1.78 times price plus 179 plus 101 times summer. But what value does the column, the summer, take if times are normal? It's a 0. So we replace this with a 0. And then we've got this other term here, 197. And what do we put in for holiday? Well, again, if times are normal, holiday, it's not a holiday. And so that becomes 0. Then we can simplify, right? So anything times 0 is 0. And that leaves us with a straight line. The straight line with the original normal intercept. Now let's see what happens. So let's grab a different color. Let's see what happens during summer. So again, let's look at our original equation. We have quantity is equal to negative 178 times price plus 179 plus 101 times our summer variable. But now we said we are in summer. So our summer binary is now activated. It is a 1. And then we've got to deal with this 197 times winter holiday. But if it's the summer, it's not the winter. And so we have to put a 0 in the holiday variable. All right, so now we can simplify some more. 197 times 0, that vanishes. But now we have 179 plus 101 times 1. 101 times 1 is just 101. So let me just ignore the fact that we're multiplying by 1. We can group these two terms. Right? So this equation now simplifies to negative 178 times price plus, now it's 280. So it's 80, yeah, I did that right. 280. So notice that now we have a summer intercept, like an intercept that's equal to 280. It's not exactly equal to the summer intercept. This 101 actually tells us how much higher than the original number we are. So let me back up a second. Originally, for normal, our intercept was 179. It's this right there. Then we did all this simplifying, and we got an intercept of 280. But this gap was what our summer coefficient here actually gave us. So we added 179 to 101 and got our 280. So this number tells us how much higher our intercept has to be. We're running out of room, but let's try to squeeze one other equation in here. Let's figure out how this original regression thing that we estimated, this big old thing, simplifies for the holiday situation. So let me get rid of that, and I'll just mess with the original equation here, so I don't have to keep writing it. All right, so if we're in the holidays, then we're not summer, so this becomes a 0. But we are in the holidays, and so this is now a 1. So what does this do for us? Well, that means 101 times 0 is just 0, so that goes away whenever you're adding a 0. And then 197 times 1 is just 197, so I can ignore this part. And now I have 197 plus 179. And that's my new intercept. In other words, I took this normal situation of 179, and rather than adding, 101, now I'm adding 179. So I add 179, I'm adding 197 to 179, and I'm going to get my new intercept. So this is now 2, what's 197 plus 179? It is 276. Gosh, I hope I did that right. All right, so we can see that if we just had those 2 additional variables, this summer variable and the holiday variable, I can get 3 lines out of that for my 3 situations: normal, holiday, and winter. Normal, holiday, and summer. Okay, so that was kind of messy. Let's see what we can do with this. Now, we already talked about how we've got these 3 straight lines now. We had 1, 2, 3. And so we could just take this straight line information and do one of those tables like we did before in the very first video. Just do it 3 times for 3 different scenarios, and we would get 3 completely different prices. So that's not hard. What is actually a little bit harder is to figure out how to combine these 3 equations to give us one optimal price. So let's see how we can do that. Okay, so here's our equation again. And we know that we're going to want to have a table where we feed in prices and we get out quantities. The big question for us is, what do we put into here for summer and holiday if I can't put in, well, I can't put in necessarily a 1 for summer if it's normal times, or a 1 for holiday if it's a summer. I need to put in some values, and I need to have a value that kind of applies for every date. Right? We want one equation now to apply for the entire data set. And the simple answer to that is we want to put in an average value for this variable and an average value for this variable. So average summer and average holiday. Well, now let's bring up our spreadsheet and actually do this. So here's our original spreadsheet, and now I've unhidden some of these columns because I need to use them again. I need to get an average for summer and an average for holiday. Well, we know how to calculate averages from columns of numbers. The fact that these happen to be binaries, 0, 1s, doesn't change the fact that it's still an average. So let's just let's calculate that. Let's call this average summer and maybe an average holiday, and actually calculate these numbers. We know how to calculate averages in Excel. Average. And our summer column is column D, so I'm just telling it give me the average of the D column, and then average holiday is the average of E, so equals average E, oops, E to E, and so that's the average of our of these columns. Essentially what this is telling us is that about 5% of the year is holiday sales and 26% of the year is summer sales, and the remainder then is the normal days. Now that I've got these values figured out, I know what to plug in back here. So I can simplify my equation a little bit again. Right? Rather than plugging in a 1 or a 0, I'm going to plug in 0.26, and in the holiday, I'm going to plug in 0.049. Now, I'm not smart enough to do that in my head, so I'm going to do this in Excel. So what did we have? We had, I don't need these anymore. Let's hide them. We had price. We had quantity. We had to figure out revenue and then pick the best one of those. And if I remember correctly, we did $5 increments. So let's fill that in. Okay, so what do we get for quantity? Remember, quantity is now a slightly bigger equation. It's not just that we're plugging in price. We got to plug in these other things as well. But that's not a big deal. We can do that. All right, so what was our equation? It was negative 178 times price. So it was this I-20. It's always going to be I-20, so I'm going to anchor that down, times whatever price we're considering, which happens to be this in this row. Then we had plus 179. So that was exactly 179.14. So that's I-17. I-17. It's always I-17, so we're going to anchor that down. And then we've got to do this part where it's 101 times summer. Let's do that. So we continue with our equation. 101 times summer was actually I-18 times summer. I-18. And then what are we doing for summer? It's the average summer. So it's going to be here S1 times S1. We're almost done. We just got to do this last part, the 197 times holiday, plus 197 times holiday. So here we go, plus 197 was actually column I, cell 19, times holiday. But remember, we're going to plug in 0.049, the average value for holiday, which I happen to have here in my cell S2. And so we put in an S2, 2, there we go. And we have it. So according to this, if my price is 0, I'm going to sell 215 units of my good. If the price were 5, then I'm selling more. Oh no, that's less. 206. I was going to say if it's more, something's wrong. And we can just copy our formula down. All right, so we can see that as the price increases, the quantity that we sell drops. But there is going to be some sweet spot for us that's going to maximize revenue. Remember, revenue is, again, price times quantity. So price times quantity. We copy that formula down, make it a little bit more readable. Let's get rid of those decimals. What's the optimal quantity and price? The highest number that we have here looks to be 64.85. It's right here. So according to our multivariate regression analysis, if we had to pick one price for the entire year, it would be $60. That'll give us a quantity of 108 and the highest possible revenue for ourselves of, in this case, 6,485. So there are quite a few steps here, but the overall idea is pretty consistent. The overall idea is you're going to use your data to estimate the equation for demand. It may be a simple binary equation, it may be a multivariate equation, but it's still a demand curve. And then you're going to use that demand curve, feed in a bunch of prices, get quantities out of it. Those are predicted quantities. And then multiply price times quantity to give you revenue, and then pick your best. The real complication was really just knowing what the output of that regression table actually signifies. And it signifies this, that it's each variable has got its associated coefficient, and we need to know what our intercept is and how to deal with these new binary variables. Finally, the other complication is what values do we feed in for our binary variables? We need to feed in the average of those variables. So that's the extra step. But once you've got this, then it's just a straight line, right? If we wanted to, we could multiply 101 times 0.26. In fact, I'm going to do this on my cell phone so that I don't mess with the screen. 101 times 0.26 is 2626. All right, right, so that's 2626. And then 197 times 0.049 gives us 9.6. And so this equation really is negative 178 times price plus 179 plus this plus that. So 179 plus 26.26 plus 9.65 is this average demand curve over all 3 seasons. So this equation is really what we plugged into our table and then kept plugging in different prices. Again, the big question is, how do you set up this equation and what do you feed in there? You feed in the averages. So anyway, that's the final video for helping you out on the problem set for estimating demand. Your homework or your problem set will have a few more variables. So it's not just summer and holiday, but it could be other ones as well. The idea is the same as it is just now. You want to write out your equation, enter average values, simplify, and then you're off and running with your usual table. So I hope this helps, and good luck. Bye.